Hello everyone and welcome to a new discussion which we are going to have on attributes classification methods. As you know that our GIS data is of two types. One is spatial data which includes vector data, raster data and TIN, and various types of vector data, two types of raster data and one type of TIN. Same way we also have the non-spatial data or attributes data. And we will be going through the classification methods, how these can be classified, and we can take advantage of different classification methods which are available. So, in the classification, basically when we are having a continuous data, sometimes it is difficult to make sense out of continuous data, and therefore our brain or humans are more comfortable to use data in different categories, means in different classes. And therefore, when we are having a continuous data, sometimes we have to do sort of discretization. For example, if I am having a digital elevation model which will be showing a continuous elevation values for a terrain in any of area, but if I want to create a classification, that means I can create using certain classification, I can create a relief map which may be more understandable to many humans. So, these use of categories is very common in that. Now, in basically what we do in classification, that we organize or reorganize data into different groups or categories, and sometimes maybe based on statistical techniques or sometimes as per our requirements also, that we can group them into or categorize them according to our requirements or depending on the characteristics of the attribute data as well. Now, classification in GIS is used in cartography, in remote sensing, and then in the field of digital image processing of remote sensing, there are a lot of classification techniques are there. Even some are based on neural network and most modern techniques are there. But in GIS, especially for attribute classification, we need not to go to that extent. Very simple classification methods are available, and these so far the 6 classification methods for attribute data classification have been implemented into GIS, which we see commonly in different GIS softwares. So, we will take one by one this discussion, but let me first bring all 6 classification methods. So, first one is the most common one is the equal interval, and by default also in many softwares you would find that whenever you try to attempt a classification of attribute data, this will you would see in the default equal interval dividing. For example, you are having a digital elevation model, values are varying between say 0 to 100 meter. Now, you can classify in say 5 categories, 0 to 20, 21 to 40, 41 to 60, something like that. So, dividing in equal slices like a loaf of a bread. Now, there can be another method which is called natural breaks or Jenks, which is based on Jenks algorithm, and this is very common while we also use in case of awarding grades to the students. We find the natural breaks. Where large gap is there, a new class can be created, something like that. So, a new grade can be assigned. So, it is based on again a statistical technique and especially given by the Jenks or Jenks formula. And third category or third type of classification method is quantile, which we will see in details in that. Equal area, or rather than having controls over attribute values, we can involve even area, that I want equal area classification, so that now the number of pixels or cells will also be counted in this classification, which we will see again detail about this. And then the fifth one is the standard deviation, typical statistical technique, and the most recent one which has been implemented in various GIS softwares is geometrical interval. So, let us start with the first method, which is the classification based on equal distance, and why we are doing, as we know, that from continuous data we want to discretize or bring them in different categories. And as you know, the purpose of these classification techniques are basically twofold. To make reading and understanding a map or a digital elevation model or a raster data much easier. For example, if you are having a color composite of a satellite image, now if some expert can classify that image and can provide a map, say land use map of different categories, that would be more useful for many people rather than just going through the satellite image, because many people may not be able to interpret satellite images easily as an expert. So, an expert can do the classification into different categories, and then that map becomes much more understandable and usable also. And also sometimes we use classification to hide something or to highlight something, and that way it is also very, very useful. Again, in digital elevation or in digital image processing technique, there is a technique which is called density slicing. So, or masking. So, we can also do that kind of classification. Now, first one is equal interval. How equal interval is very simple, that the entire range of values, attribute values are divided into equal size categories or sub ranges. Here is an example is given. At the top what you are seeing a digital elevation model, and then it has been categorized into 3 equal sized subcategories and or categories having different elevation ranges. And then though if I am interested in particular height of elevations, I am interested for some kind of project, then I can focus very well in the center part rather than maybe little difficult for this continuous data. So, this is basically what we are doing. A continuous data is being discretized into different categories. So, this category word is also used instead of directly maybe the classification, like a software like ArcGIS, they use the word category. So, you may not be getting directly the word this one, but when you go in the category, then you get the different classification method. And when we will have demo also on these classification methods as well. Now, the second one is the natural breaks, which is based on the Jenks optimization or Jenks formula. And basically this method identifies the breakpoints or gaps in the data, a sufficient or large gap in the data, and which is based on a statistical formula. Now, this method is of course complex than equal interval method relative to that, but it is basically what this method does, it minimizes the sum of variance. So, within a category the variance is very little, and between two categories you are having a large gap. So, this is what the Jenks optimization technique is, that it minimizes the sum of variance within each of the class. And natural breaks finds basically groupings and patterns inherent in your data, which you may not identify, may not see, or may not be visible to you in a continuous data. But when you put this type of classification over that data, then you can find the natural breaks, groupings, and of course whatever the pattern which was inherent in the data set will also get highlighted. Third type of attribute classification method is quantile. Again, in quantile the same digital elevation model is taken, and in the next the output you are having different classes, and these classes are having basically say frequency based classification. So, that means each class is having same number of cells or pixels in it, and these quantile classes are perhaps the easiest to understand, but they can be sometimes misleading from the data input data point of view. So, one has to be really careful, and remember only that first rule of GIS, that after each and every step check for errors. So, if it is misleading, you may choose some other method of attribute classification. Now here, because it is frequency based, so say the total count is there, the population count, and which is just opposed to the density or percentage, and for example are usually not suitable for this quantile classification. Only for a few places are highlighted, highly populated. So if you are having a surface which is representing population counts, and which is already having some concentration of population or high density of population, then this kind of classification may not be good. But it means also that different classifications, all classifications are not suitable for all types of data. So it depends on how the data is distributed within one your data set or within one file. If data is well distributed, then various types of classification can be employed. But if there is a already inherent groups are there, then all classification will not suit that one. And so one has to be little judicious about that. And before that, the best technique is, before that, study the histogram or distribution of the values with reference to the frequency through this histogram. And that will, the histogram, study of histogram will let you know that which classification you can adopt and can give better results, rather than just trying one after another. So always it is better to study simple statistics like what is the minimum, maximum, mean, mode, and then histogram. And histogram, when we will have the demo, we will discuss that part also, that how after seeing the histogram you can decide. And this if you are having highly populated places in one data set, within one data set, then a small number of classes may give you the wrong interpretation of the data set through classification. So the best thing is in that case that you can increase the number of classes. Now if data is linearly distributed, then quantile is the best suited classification for attribute data. Now this one is the equal area one. In this method, this fourth method, the equal area as says that now it is going to again count the number of cells, because each cell will have its own spatial resolution. So by which we can bring the area also. So this method basically classifies say polygon features. Also you can apply on the raster data by finding breakpoints, so that the total area of the polygons in each class is approximately the same, and that is why it is called equal area. So in some special kind of requirements or projects, we may resort to this type of classification also. Now here in equal area classification, the classes are determined with the equal area method, which are similar to the quantile when the sizes of all features are roughly the same. Because in quantile also we are using the frequency of the occurrence of individual cell values. Now equal area will differ from quantile on one account, that features are vastly different areas. Now the fifth one is the standard deviation, which is purely a statistical based technique. So in this method, the mean value is found first, and then class breaks above and below mean at intervals of quarter, half or one standard deviations are placed until all data values are contained within the class. This is a very standard way of using standard deviation method. So by this we can know that different classes, and which are below standard deviation, which are higher standard deviation, and the mean part also. As said also that before going for classification, it is always good to first check simple statistics, minimum, maximum, mean, mode and histogram, and then you can know very well that which classification should be employed. Now in this standard deviation classification, the values are aggregated, and those are beyond 3 standard deviations from the mean into 2 classes. greater than 3 standard deviation above mean and less than 3 standard deviation below the mean. So, likewise -3 +3, all these values can be accommodated. After this discussion, we will also see a comparison of different classifications over the same data set, and we will see that how a classification can bring completely different results. Different classification can bring on the same data set. So, before that I would like to discuss the last classification method which has recently been employed or implemented into GIS, that is a geometrical method. Now, these are like from quantile there is slight variation to equal area. Similarly, it is also slight variation. So, these variants now have started coming. In this geometrical classification method, where the class breaks are placed on class intervals that have a geometrical series. So, using that geometrical series we can classify. So, here on the left data or left image, what you are seeing, the original input digital elevation model, and through this geometrical classification when we perform we get a result something like that. So, different classification methods will produce different results. If anybody is interested further to know about the geometric series and how it has been implemented, then here you can find detail even in the Wikipedia, and this is of course based on mathematical geometric series, and which has been implemented into GIS. And now in this geometric geometric coefficient in this classifier can change once to its inverse to optimize class ranges, because you cannot or one should not go for large size of class ranges, so that they group together. And this algorithm, geometric classification algorithm, creates these geometrical intervals again by minimizing the square sum of elements per class. So, in Genk it minimizes the sum of variance, here the square sum of variance basically. So, by which we can achieve a different classification and sometimes maybe better classification. Now, this geometrical classification also ensured that each class range has approximately the same number of values. So, it is basically balancing the frequency of each values or range of values in each class, and that has changed between intervals is fairly constant between different classes. And this algorithm was specially designed to accommodate continuous data. So, for continuous data, because like a digital elevation model or a satellite image which is a continuous data, this algorithm may work very well, or this approach of classification may work very well in many cases. But again, different classification techniques may be applicable not to all but to some. Now, this geometric classification produces the result that is visually appealing and cartographically also comprehensive, means if people can understand much easier. Now, as mentioned that it minimizes the variance within the class and can even work reasonably well on data that is not normally distributed. And only in ideal cases you would find the data is normally distributed, otherwise there might be some skewness in the data, and therefore such kind of classification can give us better results. And this classification method is also called smart quantiles, because it is variant from the quantile method which we have discussed earlier. Now, as mentioned earlier, that here the example is not from continuous data but from a vector data or a polygon data. So, what you are seeing that the same data set has been classified into different using different classification, and very interestingly, out of these 5 scenarios or 5 classifications, 4 are having same number of classes, that is 5. So, this is also having 5, this is also having 5, this also having 5, and this one. except this in this standard deviation where we are having 7 classes. Now, so if we see the equal interval, this may not give us very good results in this particular case. So, this is the population data against each land record, and it is having a equal interval size, that 3 to 6, 6 to 9, 9 to 12 and so on. And of course, number of classes are 5 here. But when the same data set is subjected to a quantile classification or a natural breaks classification, which is based on Jenks optimization method, then it is giving completely different results. And these classes again, like in quantile 2.7 to 6.3 and now 6.3 to 6.8, and within each class you are seeing, and if you see from contrast point of view, then this quantile is giving better contrast, that individual polygons or individual classes are coming very clearly as compared to equal interval. But this is data specific. It may not be true in all the cases. How the data is distributed, what is the histogram, how it is other statistical parameter, based on that only. So, in this particular example, quantile is giving quite good results. Then natural breaks, again 3 to 6, 6 to 7 here. So, the range is changing here. It is 3 to 6 and then 6 to 7, just 1% difference, and still it is giving better results than your equal interval. Now, when we compare with this the geometrical interval or geometrical method, again the 5 classes are there. It is again giving different results as compared to top 3 classification methods. So, this is the point which I was emphasizing, that different classification methods on the same data set may give different results, and when you change the data set, apply again the same classification, you would end up with different results. So, basically the results are depending on the distribution of the data and statistics of the data. So, like finally this standard deviation where you are having 7 ranges and the deviation from the mean here. So, you are having say this one is almost mean, then you are having minus values and plus values, and likewise colors remaining 4 are having just shades of blue, but here the different colors are given. That doesn't, colors are not important, the values are important, distribution is important. Color we can assign any color. So, this also we say in GIS that colors do not matter. What matters, the values of either polygon or attribute or like cell value or pixel value, that matters. We can assign any color scheme to that one. So, now there is another method which is the 7th one, and which is of course implemented in all GIS softwares, which is custom design classification or manual classification. And manual classification is done to emphasize a particular range of values, and such as that above or below a threshold value. It is something like a density slicing as per user requirements. I want to mask everything except a area which is having elevation say at a particular height. So, I want to see the for a hilly terrain like Himalaya, I want to see only those areas where snow falls. So, if I know that roughly around 2000 meters and above the snow is there, so I want to mask everything which is below 2000 and will get only 2000 and above, something like this. The same input data, digital elevation model, it has been subjected to this manual classification or density slicing. Everything has been marked, only this one. Such classifications are very useful on in case of studies of flooding or other cases, where we want to know which are the areas which will not get inundated even in any kind of flooding, and these areas then can be chosen to move people before the flooding. And this happens in the planning also, in the these natural disasters agencies are doing nowadays. They are planning the areas which are higher grounds relatively, and then they will put the people there during flooding or any other events which like in cyclone and other things. So, we through this manual classification, our ultimate aim to emphasize the areas below a certain elevation levels that are susceptible to flooding, that is the example, or emphasize the areas which is above certain elevation, for example snow areas or snow covered areas. Let me give you some example from my own work or experience. Very quickly I will cover. This is related with the classification of polygons, and what you are seeing here, that equal interval has been followed here. Very simple, very standard one, and this classification was done on the rural houses percentage, and assuming that houses in rural areas in India are not very designed house or are having used cement or RCC houses or columns and beams. They are just maybe made from mud and other things or stone and other things. So, they are vulnerable during earthquake events. And as you know that there were an earthquake in Latur about 3 decades back, and at that time we analyzed this data, of course after some time that, and what we found that you see here that 70 to 80% of the houses in Latur are rural type of houses, or we say in Hindi kacha houses. Now these houses are not engineered houses, and large number of people died because of houses. As you know that earthquakes do not kill. This is the houses or buildings which kill the humans, not earthquakes. What I am trying to say, if I am standing in an open ground where in the surrounding no buildings are there, even a 9 magnitude earthquake comes, I will not have any harm whatsoever. Only for a few seconds during that event, I may be having some movement or something uneasy feeling, but only during that period. But if I am inside a kacha house, earthquake comes, even a 6 magnitude can damage that house, and then can be life threatening also. So, this is what exactly happened, that in case of Latur earthquake, 70 to 80% of people and houses were rural houses, and therefore lot of deaths have occurred. Now, when we compared this data about the Jabalpur, which later on in Madhya Pradesh it has occurred in Jabalpur, and you see the percentage houses. Here what we are getting, rural houses percentage is much higher, and rural houses percentage is really low, around 40%. Instead of in case of Latur 70 to 80% were rural houses, here much lower percentage of rural houses. Almost same magnitude earthquake also occurred in Jabalpur after few years of this Latur earthquake, and there were hardly any death because of the number of houses or percentage of houses were urban houses rather than rural houses or were engineered houses. So, and even a simple data set through such classifications we can highlight these points. Now, further if we study this, what we find that there were, because there is a fault which Narmada Son fault or lineament which was active during Jabalpur earthquake also. So, after that earthquake people talked that if further an earthquake occurs in a progression or propagates along that fault line, then Khandwa or Khargon, these two districts are further vulnerable. If there were an earthquake, you can think that what would happen, that 70 to 80% of houses are rural houses, means kacha houses. Luckily that earthquake has not occurred. So, what I am trying to say that using simple classification techniques, even in equal interval on the real data sets, this is based on the census data. On real data sets, we can identify the problems, the causes, why it has happened, one, and how to plan. So, suppose the earthquake earlier it has occurred in Jabalpur, Now in future, suppose it occurs on Khandwa and Khargaon. Now it is this is the time to prepare people, because we know currently that they are having 70 to 80% rural houses or kacha houses. In case of Jabalpur, hardly any person died because of a collapse of house. There were hardly any collapse. But if it happens in Khargaon and Khandwa, large number of population will die because of collapse of houses or damage to the houses, as happened in case of Latur. So simple classification methods can really help us to find out not only the causes, but also it can help in the planning stages. And this is what I was mentioning, that after that Jabalpur earthquake, lot of information came. This earthquake, Jabalpur earthquake occurred in 97. I was forgetting the year. And so later on, of course, luckily the earthquake did not occur, but this is how. So this is just everything in summary, that rural population is this much, urban population is this much in different districts. And if you compare with Jabalpur, they are in the worst situation, especially the Khargaon, where the people expected, seismologists thought, and rural population or rural houses about 84%. Just compare 56% roughly of Jabalpur, and in 79% or 80% in Latur, and thousands of people died in Latur. And if the similar magnitude earthquake would have occurred in Khargaon, more number of people have died compared to Latur, because of just poor house and poor construction of houses using like mud or stones. So a simple classification can give us really insight about the data and application, and can also explain the causes and can also help in planning. So with this I end this discussion. Thank you very much.